All right, welcome. This is the first video I'm making here. Still kind of testing things out, and I still don't have a stylus, so excuse it if it's a little bit sloppy, but I'll try my best. This video will be going over section 10.4, solving trigonometric equations. We've already done a bunch on this back in chapter 8, so most of this is just going to kind of be adding some new strategies and kind of adding our new identities using kind of mostly the double angle formulas here. So let's kind of just jump right into it. So here's the general strategy. So this first one, if the equation involves functions of 2x and x. So what I would mean by that is if it was like sine 2x equals sine x. That would be an equation that involves functions of both 2x and x. What you can do there is you can easily transform this left side into a function of just x using our trig identities. So I would change that left side into 2 sine x cosine x equals sine x, and then you can just solve from there. You'll see a full example of this later in the slide. So the second thing is if an equation involves only functions of 2x, usually easier to solve for 2x first and then solve for x. So something like that would look like if we had 2 sine 2x equals 1. All right, what we want to do there is just solve for 2x and then solve for x after that. And once again, I will show you in more detail what that looks like when we get to the examples. And this last one, be careful not to lose roots when you divide both sides of an equation by a function of the variable. So that's going to be important and something that we've kind of already seen before. So something like this, if you have 2 sine x or 2 sine squared x equals sine x, you cannot just divide both sides by sine x and just have it be 2 sine x equals 1. Doing that will make you lose a root. Okay, so that was kind of the same caution from back in chapter 8. That still applies here as well. So let's just jump right into some examples here. So I have this first one. Solve cosine 2x equals 1 minus sine x. And here is our just kind of domain for x, 0 to 2 pi. That should kind of look familiar from before. All right, so a lot of the problems in the book, they have kind of a couple methods. The first method is kind of using the calculator. Most of this, we're going to do this without a calculator, so I'll kind of show you the methodology there. And here we have an example of a problem that is in both 2x and x. All right, so if you remember the strategy from the last slide, that was that we wanted to convert this into just functions of x. So I'm going to use an identity to convert that cosine 2x into just a function of x. Now we know we have a lot of options for cosine 2x, but one of them is going to make the most sense here, and that's going to be the 1 minus 2 sine squared x one. The reason being is because the other side of my equation, I also have it just in terms of sine. So we want to get the entire equation in terms of a single trig function. All right, excuse how sloppy that looks. Hopefully you can get the general idea. So the next step is I'm just going to get everything onto one side and factor it. So luckily the ones will cancel out, okay? And I can just get, and then just basically add the 2 sine squared over. So I'd have 2 sine squared x minus sine x equals 0. And now this looks like something that we've solved from way back when. We may need a little bit of review on it, but it shouldn't be that bad. Both of these terms have a common factor of sine x. So I'm just going to factor out sine x here. Oops. So I'd have sine x factored out, and then inside the parentheses 2 sine x minus 1. Great. Take both of my factors, set them equal to 0. So I'll have sine x equals 0 and 2 sine x minus 1 equals 0. So sine x equals 0 in terms of our domain 0 to 2 pi. That'll take place at 0 and pi. Okay. Maybe helpful to have a unit circle handy if you've forgotten that. This one we can just finish off. So add the 1 over, divide by 2. We'll just get sine x equals 1/2. And so that'll take place at pi over 6 and 5 pi over 6. All right, so there you have it. Not too bad, and as I said before, all right, kind of a review of things we've done before, just kind of adding in our new kind of information with the 2x. So let's move on to example 2. So here we have 3 cosine 2x plus cosine x equals 2. All right, this one's going to look very similar to the one we just did. All right, and it's going to be another example where I have it in terms of 2x and x. And the strategy there was, let's try and get the whole thing in terms of just x. All right, so I'm going to use, once again, for the cosine 2x, I have a bunch of options there. But the one that makes most sense here is because I have the rest of the thing in terms of cosine. I'm going to use the cosine 2x formula, which is strictly in terms of cosine. So that first step is to make that substitution. So I'll have 3 times 2 cosine squared plus cosine x equals 2. All right, sorry if I do a bunch of tongue motions while I try to concentrate. That's something I do. Anyway, I'm just going to multiply through by the 3 here and bring that 2 over. So I'll have 6 cosine squared x minus 3 plus cosine x minus 2 equals 0. All right, so combine my like terms. You can see I'm just going to have a quadratic here. So I'll have 6 cosine squared x plus cosine x minus 5 equals 0. All right, so beautiful, very sloppy, but you can tell what's going on. So now I need to factor this. I know some of us are still a little bit struggling on factoring when we have this coefficient on the x squared term. If you want, you can use that slip and slide method, and that's above me. But here, I would just factor this. So I know that the final terms are going to have to be 5 and 1, with one of them being positive, one of them being negative. So just trying some combinations here. If I had 6 cosine x and cosine x. Okay, so I need this to be positive here. So if I do negative 6 plus 5, so therefore minus 5 here, plus 1. All right, so that'll work, because if we FOIL it back out, we get that negative, we get the 6 cosine squared x minus 5 cosine x, and the plus cosine x will get us the plus 1 cosine x minus 5 equals 0. And so now, once again, we're just solving each of these factors. So this term here would just be cosine x equals 5/6. And this one will be cosine x equals -1. So this term I can do, this cosine x equals -1, I can do that without using a calculator. Be pi. Great. And so for this term, I'm going to have to use my calculator. So I'll have to do inverse cosine of 5/6. Okay, make sure you're in radians. And what that'll get me, if I do that on my calculator, I would get approximately 0.59. Whoops. Okay, having trouble drawing a dot there. There we go. All right. And so remember, that's not going to be the only answer. We're going to need our other value as well. We know that cosine is going to be positive in both the first quadrant and the fourth quadrant. So the other one is going to be at 2 pi minus 0.59, which would get us approximately 5.70. And so there are my three solutions. We'll have pi, 0.059, and 0.570. Sorry, that is a rough 7 there, but there we go. All right, on to the third example. Okay, so this one is one of the first one we've dealt with so far, where it's strictly in terms of 2x, okay, instead of being both in terms of x and 2x. So what we're going to do is just solve this in terms of 2x, and then after that we can convert it back to x. So if you remember, we did an example of this before, I think, back in chapter 8, but it wasn't really a focus. So if we're solving for 2x, we're going to need to adjust our domain, okay? So if x is between 0 and 360, 2x is going to have to be between 0 and 720. How did I get that? I just multiplied each of my endpoints by 2. Okay, so that's what we're going to have kind of be thinking about in terms of this problem. All right. Otherwise, the initial steps are very similar, so let's try and isolate the sine 2x here. That's just going to be dividing by 2. So I'll have sine 2x equals 1/2. All right, so I know for sine being 1/2, all right, I'm in degrees here, so I know that's going to take place at 30 degrees and 150 degrees. All right, that's in the first rotation around the unit circle. So that's from 0 to 360. Okay. However, I need to account for the next rotation as well. Okay. Once you have these initial answers, though, it's very easy to get the next two. All you need to do is just add 360 to both of those to get those coterminal angles. So 30 plus 360, that'll just be 390. 150 plus 360, that's going to be 510. All right, so those are not going to be our final answers because those are the values what 2x equals, and we're trying to solve for x. Luckily, it's very easy to figure out what x equals once you have what 2x equals. All we got to do is just divide each of these angles by 2. So 30 divided by 2, we'll have 15 degrees. 150 degrees divided by 2, we'll have 75 degrees. 390 divided by 2, we'll have 195 degrees. And 510 divided by 2, we'll have 255 degrees. And there we have our final answers, those four right here. Okay, so just basically, the hardest kind of step there is just basically we got to make our new domain, which we did up here, for the values of 2x as opposed to x. Okay, once we did that, all we did was just solve for sine 2x. All right, and that's very similar to what we did back in chapter 8. You get the value of 2x. All right, and sometimes these are easy to miss because you got to think about that extra revolution around all the way to 720. Once you have those values of 2x, we just divide each one by 2, and there we get our values of x. All right, last example here. Okay, it's going to be another one where we have ones in terms of both 2x and x. All right, so but this time we're in degrees. Okay, so same situation we did before. We want to convert it all into functions of x. All right, and then we want to solve it. So I'm going to use an identity to convert this cosine 2x into just a function of x. All right, I'm going to choose, remember there's multiple options for the cosine 2x, but once again, I'm just going to choose the one that keeps it all in terms of cosine, because I can see that's what I'm going to have on the other side there. So 2 cosine squared x minus 1. I'll move the cosine x over right now. Do a little bit of rearranging because I'm going to want to try and factor this if possible. All right, so that's not too bad to factor. We could do 2 cosine x plus 1 times cosine x minus 1. All right, once we have our factors there, we'll have 2 cosine x plus 1 equals 0. Cosine x minus 1 equals 0. Solve for cosine in both of these, so cosine x equals negative 1/2, and cosine x equals 1. All right, so cosine x equals 1, that's just going to be at 0 degrees. Cosine x equals negative 1/2, those will take place at 120 degrees and 240 degrees. And there we have it. Those are our 3 answers right there. All right, so that's it. Please let me know any kind of feedback on this video. If I went too fast or if it's too sloppy that you couldn't read it, please let me know. And yeah, thanks. Hope this helps.